All right, let's have a look at this problem called minimum rounds to complete all tasks. Okay, let's have a read. We are given a zero indexed array tasks where tasks of I represents the difficulty level of a task. Okay. In each round, you can complete either 2 or 3 tasks of the same difficulty level. Return the minimum rounds required to complete all tasks, or -1 if it is not possible to complete all the tasks. So here's an example: 2, 2, 3, 3, 2. So obviously we have to pick up tasks based on their difficulty level, right? So let's quickly see the first example. What are the different, how many tasks are there for each difficulty? So for difficulty 2, there are 3 difficulties: difficulty 2, difficulty 3, and difficulty 4. Difficulty 2, we see there are 3 different tasks. In difficulty 3, we have 2 tasks. In difficulty 4, we have 5 tasks, right? So this can be completed 3 tasks. So at any point, we can either do 2 tasks or 3 tasks of same difficulty level. So for completing all the tasks of difficulty level 2, it will take us 1 round because we can complete it in like 1 round. We can do 3 tasks, right? For again for difficulty 3, we'll take 1 round, right? Because it's so you'll do 3 times 1, and this you will do 2 times 1. And for 5, how many rounds will take? So we'll first maybe we'll do 3 and then we'll do 2, right? So 2 rounds will be needed, and it will be okay. So 1 round of 3 and 1 round of 2. Right? That is a general idea. So the first question is, can we complete all or not, right? And if you're completing all, then for example, let's say there was another difficulty level 6, and it had let's say 6 tasks. So now here you could do 3 rounds of 2, or you could do 2 rounds of 3. We have to minimize. So we'll first always try to do as many 3 as we can do, right? So here also we'll probably take 2 rounds, and we'll do 3 times 2. What about, let's say, there was a task with just a difficulty with just one task, then it's not possible, right? So in 1 round, you will do at least 2 or 3. You can't do more, you can't do less. So not possible. What are other scenarios? So in general, what we're trying to solve for is, given any count of task for a difficulty, we have to solve for, hey, 3 times x, right? 3 rounds of x rounds of 3, and let's say y rounds of 2. It should come as the count where uh, well, x is greater than equals to 0, y is greater than equals to 0, and we are saying that count is greater than 0, right? There is some count. Now, obviously, for count equals to 1, it does not work, right? Count equals to 2, we can see x equals to 0, you get y equals to 1, count equals to 2 work, count equals to 3 works, and so on and so forth, everything works. So basically, and also we want to, if multiple solutions are possible, we have to choose the one with the largest x, right? That's what we're trying to solve for. So to minimize the number of rounds, sorry, the yeah largest x, right? Because the more x are there, that means more rounds of 3 you are doing. Overall, you will be doing lesser rounds, right? So let's look at a number. When you divide it by 3, you can get how many remainders. So either a number can be represented as 3x plus 0, right? Or it can be 3x plus 1, or it can be 3x plus 2. That's all right, because 3x plus 3 is essentially 3 times x plus 1 plus 0. So basically, when you divide something by 3, you're likely to get these 3 remainders, either 0, 1, or 2, right? Any number. Now, so this can be written as 3 rounds of x, and that's it. So that's all those numbers which you give remainder 0, they can just you can do. So essentially, they are fine, like you can solve for them. Now for 3x plus 1, you can't do one task, right? That's not allowed. First of all, let's look at this: 3x plus 2. So 3x plus 2 you can write as 3, so x rounds of 3, and 1 round of 2. So even these can be solved. What about this 3x plus 1? Can they be solved? You can't do one task, right? You have to at least do either 2 or 3. So, but we can write this can be written as 3 times you can do x minus 1 rounds, right? And so you get 3x minus 3, so you do plus 3 and then plus 1, right? So essentially it becomes 3x plus 4, which is essentially 2 times 2, right? So even 3x plus 1, the all the tasks that give remainder as 1 can also be solved, right? You do this, right? So now let's look at so your three possibilities. uh, Remainder equals to count percentile 3, and if r equals to 0 or r equals to 1 or r equals to 2, right? So for r equals to 0, you're saying these many rounds will be required, right? Count by 3 rounds. For r equals to 2 also, it's quite easy. You will do count by 3, which is x, plus 1 round for 2 will be required. For r equals to 1, what you're saying is x minus 1. So whatever you divide this by, so count by 3 minus 1. These many rounds of 3 will be done and 2 rounds of 2 will be done, right? Which essentially is plus minus 1 plus 2 is essentially plus 1. So both of these come out to be same exactly. So there are two cases. Either your remainder is 0 when you divide it by 3, or your remainder is 1 or 2, in which case these many rounds are required. What is the exception? Well, the exception here is, for this case, your x minus 1 cannot be negative, right? So if x equals to 0, that is not allowed, which is 1, right? That's the only case. So the only case that doesn't, only uh, invalid case is count equals to 1, right? Everything else can be written in this format and works out. Even 1 can be written, but then for 1, 3x, x equals to 0 plus 1 doesn't work out because you want to have at least one round of 2, right? So you get figured out. So just 1 doesn't work, right? So let's try and write the code based on this logic. So what we first we have to then get the count for each and every difficulty. So we can use a hash map for that. So let's do a hash map, integer. Let's call it difficulty count, right? Diffi count equals to new hash map. Let's go through each and every task. So for each task in task, let's increase the count of this difficulty. So for each other, let's call it for each difficulty, right? So for each difficulty, let's increase its count. So we'll get difficulty count dot put in. For this difficulty, add its frequency. So you go 1 plus what is the current value. So you can do get or default, uh, and if it's not present, we'll set it to 1 plus 0. Otherwise, we'll set it to 1 plus the current value, right? So we get these count of each and every difficulty. Then we go through each and every difficulty. So for each difficulty in, so now we are going through each and every difficulty and we check what. So we get its count. So its count is, and let's calculate the number of rounds, right? That's what we essentially want. So rounds equals to 0. Now first thing to check is if count equals to 1, that there is a problem, then you just return 0, that or whatever it says. If it's not possible, return minus 1. So then we return minus 1. It's just not possible. Else if count percentile 3 is 0, that was the case, we were returning just count by 3. Rather, we add the number of rounds. So rounds plus equals to count by 3. And if the other case is uh, the remaining case where you do round plus equals to count by 3 plus 1, right? That is these two cases. So that's it. Now we called it rounds, and we then return these rounds. All right. So that's our logic. Let's submit and see if it works. And it does work. All right, so that is it.